Let's kick off forecasting new product launches with limited data. Today, we have a great panel of speakers. I'm excited to introduce Dr. Jahangir Amjad. He's our head of AI platform at Ikigai Labs, and he brings a wealth of experience as a computer science lecturer at both Stanford and MIT, with a PhD in machine learning from MIT and significant contributions at Google, including work on the open source data commons project. We also have Abdullah, an ML engineer with a PhD in machine learning from MIT, who is award-winning and been recognized for his contributions to time series analysis, reinforcement learning, and causal inference. And then we have Camille Blanchette, who's been at our company for 3 years, helping customers, working with them directly in applied AI and solutions. So he specializes in advanced forecasting and has a background in neuroscience and AI. So it's quite the academic panel that we have here today. Um, to then kick off today's topic, I will also say I'm very excited about what we're talking about. This is probably one of the use cases that I think our customers get the most excited about because it is so challenging historically. So we'll be talking about new product forecasting today, and you may be thinking about that as just simply, breakthrough product forecasting for something with no track record at all, so no historical data. But there's a few flavors of that we deal with. So it might be launching a new configuration of an existing product. It could be launching, the next version in the series of products, and even looking at how you might handle complementary products. So, there's a wide variety of scenarios in which this tactic we're going to talk about today comes into practice. And before we jump into it, I just want to get a sense from the panel with a poll. Curious which of these scenarios you might be facing in your own business, if any of these are more relevant to you, just to help our speakers kind of get a sense of, who's in the audience today. So, are you launching a new product? Are you dealing with a configuration, potentially a complementary, new product, or maybe an updated version of something you've already got? So it's a multiple choice, select everything that applies. All right, let's see what we got. Okay, so pretty big mix of everything. Great. Well, then I think today's discussion will be really, really helpful. And so, with that, I will kick it off to our main speaker today, Jahangir.
Hi everyone, good to be back here. I know it's holiday season, but there is a lot of interest in this particular topic we see this across the board in our engagements with clients and in general, both as an academic and as a real world topic, introducing new things in the market, new products, as you heard, new configurations of existing products, different kinds of sizes and packaging and those sorts of variations, introducing products that go together, complementary in nature, introducing products that may be new to you, but not to the market, and keeping competitors in the view and things like that. We hear this all the time. It's a very important topic, obviously, for business planning and all sorts of forecasting reasons. And so there's no surprise to us that this is of interest to a wide variety of you who have joined us today, and some of you will be viewing the recording as well. Before I actually dive deeper into this, I wanted to sort of also make sure that we can sort of set this in the context of where this webinar series have sort of come from, culminating in the last one today. But essentially, we started off talking about forecasting as a sort of standalone entity. When you think of what would you want to do when you're forecasting, what are the use cases most commonly seen? Then we transitioned into how to do it better and better and better in terms of algorithms, different varieties and classes of algorithms. Then we went through and said, all right, if you have the best-in-class algorithms, is that enough? And typically the answer is no, you can do a lot more. You can apply some pre-processing or AI ML techniques, very well known. We covered a bunch of those to help your forecasting algorithms achieve even better accuracy. And also talk about other objectives that you may want to achieve. And last time we started pivoting from thinking about pure forecasts and pivoting away to thinking about other things, which is why where you would need the forecast. So often we will talk to people and they'll tell us forecasting is really important. We care about the accuracy, but that's not an end all, right? We are not just forecasting for the sake of forecasting. We are usually trying to tie the forecast to some sort of a planning exercise. Trying to tinker with some scenario plannings, trying to tinker with what ifs, trying to sort of figure out if you change the inputs, the ingredients that go into the forecasting, how would the outputs change? And how could you principally approach that sort of a scenario planning exercise and use your forecast to essentially provide you with a range of possibilities when that makes sense. And we discuss things like price elasticity, introducing products, sort of talking about products that may compete with each other, talking about demand for things that may or may not be elastic. How do you view some of those things? We talked about it briefly as examples. And today, we're going to sort of focus on this view of let's introduce, if we wanted to introduce something new, a new product like you heard, or a configuration or a complementary product, or something with essentially very limited history. How do you go about approaching it? And my goal today is to essentially steer us towards recognizing that everything that we have pretty much discussed thus far in this webinar series sort of culminates in this as one of the sort of major applications where, even though we may be thinking of this to be not related directly to a lot of stuff that we talked about previously, I'll try to make sure that I can make those links so that it becomes evident that we perceive this to be an application that ties very nicely into the world of forecasting, into the world of scenario planning, and essentially decision making. That is eventually the goal of, I'm assuming, what a lot of you are interested in your professional lives. And so I'll dive deeper into, hold on. Oh, there we go. So one thing to not forget, and I want to essentially distill some thoughts here, is why should you care? Even if if you're introducing a new product and you're trying to forecast how it would do, imagine you did it really, really well. Why should it matter? Why does it matter to you? For the same reasons that you were probably interested in forecasts even before this, which is inventory planning. In this particular case, when you're talking about new products or new introductions, you may be interested in figuring out how does it play with the mix of products and SKUs and configurations that you may already offer, or how may it alter your place in the market. Talking about impacts on sales and revenues. Are you going to end up cannibalizing your best-selling, highest margin product by introducing something new? Things like that. Are you going to be able to make a dent in the market that may already be captured by some other market leader? How does it impact supply chains? Can you even introduce, even if the product is supposed to be a bestseller by all expectations, can you actually get it to the market in a complementary way through your supply chain and without disrupting your other business, your existing business, or being able to achieve the goals? And then, of course, logistics and shipping and some of those, and store operations, obviously. Can you even stock the new one? Do you need special handling and all those sorts of things? We won't be discussing a lot of those, but of course, just like any other demand forecasting application, these are important questions that permeate through all of this. Just being able to forecast a new product may just be the sales from a new product, for instance. How well can you expect it to perform may still be just the start of what you want to do. And of course, we want to be mindful of that. And perhaps in a few minutes, we'll converge on one sort of meta application around this as well that we have worked on actively through our engagements with a couple of clients. So just generally speaking, you don't need to read the details too carefully, but essentially, what are the things that we hear when we think of thinking of new things that you may want to forecast? New things meaning there is either zero history or there is very, very limited history of that particular thing. What are typical things that we hear about? We hear about people who are experts in the field, and we never want to diminish that knowledge, who essentially can guess how well some things might perform. Things like, we hear statements like, this will probably sell like product X. This will probably not do very well. This will probably do well, usually crystallizing a lot of our existing knowledge of both the market and our own product offerings into some sort of informed opinion. And then, of course, you could use all sorts of either traditional or slightly more modern approaches. You could be spreadsheet based. You could do vanilla forecasting. You can make some assumptions. And you can encode some of what you believe from your experts into some of these things. You may end up doing something simple, which also in many cases will work, which is around just, if I know I have a similar set of products that I have already introduced and I have good data about them, maybe I'll just start off with, instead of just making a random guess, I could say take an average of some of how those things perform or have performed historically, and I'll start use that as my starting point for a forecast. I by no means do we want to diminish those things, because in the absence of absolutely no lack of any kind of information necessitates that you have progressively better ways of trying to reason about these things. And some of these are very good starts as well. We will hopefully try to guide the conversation today into what could perhaps be one principled approach in a more automated ML AI friendly fashion. But that doesn't mean we should ignore all the other goodness, that especially the expert knowledge that may already exist in your enterprises. And so, of course, I'm preaching to the choir here in trying to figure out what are the challenges with these predicting sort of early patterns of things that have not manifested already. Of course, there is limited data. There is also you may actually end up observing something that may be confounded by something entirely separate that may be going on. Maybe your holiday sales just go through the roof. But then as soon as the holidays end, there's no demand. And maybe that was the particular isolated effect and an isolated event that was perhaps giving you false information. In which case, the point being that if you did not take into account the fact that this was a holiday, or you were running a promotion, or maybe you were giving the product away for free in the beginning, you may have seen something that may not be something that you can expect to go on for longer. You need to capture all of those things into the mix. And of course, there may be seasonality, there may be weekly, daily, or holiday effect based seasonality that may be impacting things, and you need to encode all of that information. And of course, it is hard to know also and guess if the initial sort of initial forecast or initial realizations which you may have just observed with limited information, will that even persist? Do you have any basis to believe all of that or not? All of this is almost obvious in that sense that everybody we would like to assume, is already thinking about them. Some of these things, I will refer you to our past webinars where we have talked about how would you capture some of these things? How would you capture the holiday effect, or if you were running a promotion, or some of the other related information that may be impacting weather and all those sorts of things. We won't discuss a lot of that today, but just wanted to call out that, yes, this fits very nicely into that general theme, and some of the challenges there should hopefully be very self-explanatory in that sense that all of you are already thinking about. But before we get into one particular view that we bring into new product or new configuration introduction, I want to take a little digression just to set the stage for what we want to talk about in the next few minutes. Many of you who are here, I'm sure all of us have interacted with an LLM and some language model, and a lot of sort of one of the key things in language modeling, natural language understanding, which predates the transformer-based newest Gen AI iteration of language modeling, is essentially this notion of a word-to-vec. A word-to-vec essentially tries to encode semantic meaning and semantically aware, essentially encoding of text into mathematical representations, call them vectors. And you want to encode things in a way, in an ideal way, that preserves semantic meaning. So a man is to a woman what a king is to queen, the canonical example, and a woman and queen are related more to each other than, say, perhaps a man and king are. And of course, it is context dependent, all of these things. And so that was the initial sort of contribution this is now widely sort of used, at least theoretical construct or a practical construct called word-to-vec, essentially trying to capture semantic meaning from text into a mathematical representation, and then hopefully you can do interesting things if you wanted to find similar words or similar sentences, or if you want to find out if which of the n sentences that you may be looking at, which of them are saying the same thing or semantically mean the same thing, you might be able to encode those sentences or text into vector representations and then go into this vector space, like you see on the left here, and be able to find closest neighbors or who are you closest to. That's a lot of what's underpinning some of the great innovations that we've seen in language modeling as well, which is why these models are really good when they talk to you to understand that even if you didn't say exactly the same thing that they have seen in their training data, they can still understand your meaning pretty well because they can do this similarity matching in the vector space. And the reason I'm mentioning this is because we've invested a lot of time, and this is obviously not something that's only unique to Ikigai, but everybody does it in a slightly different way, in trying to work with this notion of the equivalent of a word to vec, call it time to vec, which is essentially take a time series and being able to encode them in a vector space, all time series individually, such that you can preserve relationships. And so similar time series, quote unquote, hopefully in the new vector embedding space will tend to be closer to each other, which means that you can achieve a lot of advantages of this. Number one, if you have a very long history time series, and you have many of them, you could perhaps do some data compression and essentially be able to reduce them into a smaller dimension space and really capture the essence of what makes them similar, what makes them different, and being able to run all of these sort of tasks on it. And also, of course, it helps you standardize things because now, just like in the text bases, all the algorithms that we have at our disposal run on vectors and numbers and numerics. And you've essentially taken a time series construct and converted it into something that you can throw a lot of other existing machine learning and AI machinery into it. You could produce cohorts or you could produce clusters, which we have previously talked about in this webinar series as well, in trying to figure out which may be the most similar set of time series compared to other ones which may be very different, and hopefully you do it in a way that preserves those relationships. And so that's the analogy with word2vec. And the reason I'm mentioning this here is because you could, if you believe that one can do time to vec, there are many ways of doing time to vec. Of course, technically, we don't want to go into the details here, but we can share a lot of references if you would like. It should ideally be able to then uncover, if you believe you've done a good job of that, you will hopefully then also make the leap in saying, yeah, then hopefully it can uncover some of the patterns in time series and capture the essence of those. If there are two highly seasonal time series following a very similar seasonal pattern, even if their amplitudes may be different, there may be two separately, the sales of the actual numbers, the amplitude of those series may be very different, but they may follow similar historical seasonal patterns. And then on the other end, you have something which is either flat or has a trend and no seasonality, or maybe very elastic in that straight line sense of the word. Perhaps when you want to look into who ends up being similar to the others, the seasonal ones will be closer to each other than the one that just has a flat trend, for instance. And so that's the kind of pattern capture that you would want this time to vec technique to really help you with. If you can do that well, then you can do a lot of other things. You can then start to think of clustering things, as you see visually represented here. You could essentially figure out what's behaving similarly to the others. Now that could really help, and this is where I start to sort of hopefully bring it back into the new product information, our view on that, which is if you could capture this time to vec behavior and these characteristics really well, then what can you do? As a simple exercise, you produce some clusters. Let's say you produce 2 clusters. You introduce a new time series into the mix. You could immediately then figure out who are you most similar to, for instance. And then so you can find your own cohort. And if you find your own cohort, then you can uncover a lot of other relationships. Perhaps you had limited data, and now you are finding your group, your cohort, and you can use a lot of the history of the cohort to perhaps inform in expectation how things may evolve for you in the future. Of course, now the question is, if you have no data, you have no time series, what do you do? Even if you have time series, time to vec has used history of time series to produce cohorts. If you now have a new one which has absolutely no data, what do you do? So we'll talk about that next. But essentially, you can encode a lot of information. As long as you can do that, then you can essentially try to figure out who your nearest neighbors are, who your cohorts are, who your clusters are, who you may be behaving most like in a statistical sense. And then that could help you take the leap forward into what may things look like. So now, bringing it more closer to our topic of today, if you were just looking at new product forecasting using some notion of time to vec with no history, The scenario being you want to forecast the sales of a new product without any sales information available. So how would you do that? So there are various things going on this slide. I can walk you through it a little slowly. But essentially, if you have no sales information, what do? You obviously can't create information out of nothing. And so you have to use other proxies. And in the same way that I mentioned to you that you can encode a time series into a vector representation, you can actually do a lot more. You can, in addition to time, you can also have non-time based features, features of products, for instance, the metadata of products. Metadata of things which typically you have access to for your own products and also for products in the market. Perhaps you could use those instead to do the same thing, which is use that metadata to essentially figure out what the right clusters of different types of products would be, so that for the new product that you're trying to introduce, for its metadata, you could hopefully map it back to some sort of neighborhood or some sort of a cluster. And then within that cluster, you can then say, I have history of existing products. That is the other sort of input that you had for other products, but not for the new one. And you can use that history of that cluster of those similar products to then project things out into the future or forecast them into the future for this new product. And essentially, all of them will rely on using time2vec or embedding your data, your metadata, and your historical data into a vector space, trying to find similarities, and then essentially going from there and projecting them out. A lot of them are based on nearest neighbors, or you could do something more clever. Obviously, the choice of that depends on you. This is just a very high-level introduction. On the right here, you see some visual representation of this space where each point represents perhaps a product or a series. And essentially what we're trying to encode is that if you're able to project them into this space, you can perhaps find what is most similar and what is different and draw neighborhoods around them to learn from. And then at the bottom, you see in this particular case, we had one particular engagement where we were trying to help a particular client forecast what would happen when you launch a new product. We had a lot of metadata about the product, but it wasn't ever introduced before. And so you see the actual data, which is what happened in reality. You see before October, there was nothing. There was zero sales, obviously. And then you suddenly introduced it in the market and you saw some sales. But obviously, at that time, before you had any data, when you projected it out, the dark line shows you that we were able to somewhat give you a better estimate. It's not perfect. And nobody is expecting perfect in those settings. But we were able to capture some effect. Some holiday effect was already captured. Some of the other sort of nuances were already captured. And it was better, way better than just starting out with either averages or some other guesswork. And so the next thing, of course, tied with this is, well, once you start selling this product, you now start getting some history. And so could you actually use that too? And the answer is absolutely yes. It actually should help you even more and more, because now you have more to rely on. Now you actually have some version of the product's history that's starting to materialize. And you can now take that into the vector embedding space. And try to find who are you actually behaving very similar to. Previously, you were essentially just doing it on metadata. Now you have metadata plus the history of the products, and things may move around in some space, and you can essentially then learn from there. So this you can repeat the same process now. And this visually at the bottom right, you see the same plot as before, the same green and the same dark one. But then you see a blue one, which obviously starts later because now you've observed about, in this case, 7 weeks of history. And you notice how much more closely the blue seems to be tracking the green than the dark one, because obviously it's learned from some behavior and found a better neighborhood from which to learn from. And so this is at a high level, essentially the kinds of approaches that we use, and it's adaptable from zero history, of course, and then things become better as you hopefully observe more and more history. And so some of the challenges around these obviously are, what if you don't find any good match? How do you determine that? Obviously, depending on how big a neighborhood you want to find, what the similarity scores are that you want to base on, these could become difficult challenges. But typically, the good thing is, whatever notion of similarity you're using, you typically will know when you are very far away, when you haven't found very many similar things, and when you have found very, very similar things. And of course, this is where, as you remember, I mentioned, don't throw the experts out, because the experts, the humans, you all who've dealt with your market and your products and know things really well, can really help guide things. You could help create some of those clusters, even manually, if you want to, to assist how you might project something behaving into the future. And so, you can essentially, quote unquote, correct some of the things here that the algorithm may not be able to capture or is not suited to capture, that human knowledge, for instance, may actually be able to do. And so this is a fairly flexible sort of high-level approach. The other thing I want to quickly mention before we get to the demo is essentially another sort of example, and this will hopefully bring together a couple of things we've discussed in previous webinars as well, is, all right, now we want to, let's say, take this and introduce a new configuration of an existing set of products in the market. I'll go through a little quickly. Essentially, what this is saying is you want to introduce a new configuration called D, and you already had A, B, and C in the market before. You had a bunch of data that you had already observed about it. Now, you essentially want to say, can I project things out into the future? Now, it really depends on some of the assumptions that you may actually be able to make. For instance, in one case, you see it right here, we may assume that the total demand for your products is fixed, in which case you will essentially get a cannibalization. The D that you're introducing will necessarily then show you that you're going to cannibalize the sales of the other existing configurations that you may have in the market. And that may be okay as an assumption in some cases. In some cases, that may not be enough. In another case, perhaps what you want to capture is that maybe the sales for the other things are going to remain where they are, and I can independently layer in the new product and essentially add those up and say I may actually reasonably be able to expand the market of sales for my products as well. And I assume that there is no interference and no cannibalization happening between the two. And then that may make sense in some settings, and that may not make sense in some settings, things that you need to at least consider. But ideally, we hear that nobody wants to be an either or, right? Because there are disadvantages and advantages for both approaches. And you want to essentially be able to capture both effects in some sort of a rational way together, so that you don't just forecast something independent of everything else. You don't make hard assumptions around demand being fixed. And you are essentially able to sort of see how the interference and cannibalization may actually play out with both your products, and if you have competitor product data, perhaps with the competitors as well. So you want sort of the best of both worlds. While not going into the detail of some of these things, this goes now beyond just simple new product or new configuration forecasting. Now there is more that's involved in it. And of course, those are things that you want to think about. And here's one sort of articulation. This is, I think, the second last slide that I'm going to cover here. Sort of one instance where we did something similar. We introduced a new product, worked with somebody who was introducing a new configuration. And what you see on the plot is that using the same approach from before, product metadata, history of the current products, and actually in that case, they had a history of competitor products in the market too, being able to forecast. And that's what you see on the right there. The purple line, which was the forecast with some confidence interval, and then the blue one shows you what actually happened in that back testing scenario, being able to introduce and capture that effect. And so that's great. That's what we talked about already. New product introduction. This is essentially the line here is showing you total demand. So this includes the demand for the new one and the other ones, which is usually what you are interested in. But then you could also do other things that we talked about last time, which is around what if scenario planning, which may go into issues of price elasticity, which may go into essentially this issue of whether you can expect the demand to be inelastic or elastic, whether you can expect cannibalization or not, and how do different pricing behaviors behave with each other. What if you sold the new product for $0? How can you expect things to change across the board for your products? And so that's sort of bringing the previous time together as well, where you could do two steps, where first you do some sort of set up your routine around doing a new product introduction, or new, in this case, configuration introduction. You do your forecast, but then also being able to turn the knobs and show how some of those things collectively would change as you change the pricing of either the new one, because you could price off, start off at many different levels, or you could even impact the price of other things that may exist in the market and sort of turn the knobs and see how they interact with each other. So the part here being, the point being that new product introduction on its own may be just a beginning, but there are other real world sort of things that are obviously on everybody's minds that you want to capture, and those can be captured through some of the other things that we discussed previously. And holistic sort of planning and forecasting will rely on a bunch of these techniques. So I'll stop here. We'll obviously take a break for questions as well, but I do want to give a chance to Kami, who's here today from Ikigai, to actually show you a quick demo of how some of these things look like in our platform, and then we are happy to transition to take some questions. I'll stop sharing, and Kami, I think you can share your screen after that.
Yeah, terrific. Thank you, Jahangir. So Jahangir took us through the theoretical approach in terms of our time to vec technology in the way that we forecast new solutions. My role here is to work directly with customer data and implement these time to vec techniques. So I'll start by going over what we've covered in some of the previous webinars on our application. And that's what we're looking at on screen here. And then I'll take you through the page that's currently on screen, which is our new product forecasting. And so we'll cover a lot of the same concepts that Jahangir went over, but on the actual reference application itself and with some of the practical implications that we take into account. So on the left-hand side here, we see the insights and alerts. That's one of the concepts we covered in one of our previous webinars, how we use exception-based planning. So using probabilistic models to not only produce a forecast, but also indicate to a demand planner which areas of the forecast they should investigate. What are some of the insights within that forecast? And what are some of the alerts that you should be responding to or perhaps adjusting within that forecast? We've also covered the forecasting, monitoring, and interpretation components. So the various models and multi-model layers we use to produce forecasts, the way we monitor and ensure that those forecasts remain performant, and then the understanding forecasts, so interpreting those forecasts and making use of them. And then lastly here, we've got the scenario analysis and what if analysis. So if we start to change some of the underlying assumptions about future demand or some of the underlying drivers of future demand, can we simulate future scenarios and then have a more resilient plan for those contingencies? And then in our last of these 5 webinars, today, of course, we're covering the new product forecasting, which is what we've got here. So in this case, we're simulating the introduction of a new product, this 15-inch 120 gigabyte RAM variation. And we've got a release date from November 12th. So initially, we're going to run a forecast with no data. And that's what we've got in this graph here is an initial forecast with no data. And as Jahangir covered, even when there's no data, what we can use is the product cohort that our time to vec is producing to produce a forecast for that new product. So the way we're producing this orange forecast is based on these similar products. And we've got, in this case, 5 different similar products currently weighted about 20% or 1/5 each in terms of their relevance to the new forecast for our 15-inch product. Then, and Jahangir covered this as well, if we introduce 8 weeks of data, so we've got 8 weeks of historical data on the left-hand side here, and we've been selling this product for 8 weeks. Now we've got a much more refined sense of the scale and movement of the demand for this product. And so we produce a new forecast with 8 weeks of data. And you can see that the new forecast in green tracks with the real 8-week historical data a lot better than that initial forecast. So this is showing both the way that we use these product weights and this time to vec concept for the initial forecast, but then how, of course, as we start to collect data on a new product, we're going to start to refine that forecast based on both the real data and the time to vec, or that product cohort that we're forming here. So with that, there are some practical components of new product introduction that we need to take into as well. So that's the time to vec and some of the more theoretical components that Jahangir covered. He also mentioned the expert in the loop at the beginning, that that's the most invaluable source. Every product manager, demand planner who releases a new product has an intuition for how it's going to perform. And we need to be able to take that into account. That's where expert in the loop comes in. So first, on the product cohort level, if you want to go in and compare the new product with its product cohort, so each of those neighboring products that we've formed into its product cohort based on time to vec, you can adjust which products are more weighted here. So if you have a very similar product that you want to weight, let's say 50%, then you can manually input or overwrite the time to vec weightings on that particular product. So there are ways you can intervene in the time to vec in the product cohort level. Another component that you need to be able to adjust for is if you have a certain cap on the production of a product. So in this case, let's say the yearly demand for this new product, you want to set a certain cap, and I'll just put it at 5,000 units, because that's the max that you can produce. And you want to see how that demand is going to be distributed across your different geographies, as an example. So we offer a way to set the high level yearly demand, or let's call it weekly or monthly demand for a product. And then it will then filter down to the various levels of your data hierarchy. And the example I'm using in the different geographies that demand would be distributed over. So you can set a hard cap on the demand. And then in a similar concept, if you're introducing a new variation, like in the example we have here, where it's the 15-inch 128 gigabyte RAM, you might have a constraint at the category level, where you're switching over your production from the previous models into a new model, and you've got an aggregate constraint on how much you can produce for the full category. And that's this third tab here, which is adjusting the category level demand. And so you're going to see some cannibalization from those old products into this new product. And you want to be able to set a cap at the category level to see how the demand distributes between that old variant and the new product that you've introduced. So this is a reference application that we use to demonstrate some of these concepts in the way that we implement them for customers that we have now. Of course, there are lots of variations and nuances that we need to get into for every particular type of company and product population. So hopefully this is a helpful representation of some of the concepts that Jahangir has been explaining and some of the practical components that we need to be able to overlay and involve the expert in the loop in. Alex, I'll pass it back over to you. I believe we'll get into some of the questions and answers now.
Yep. Thanks, Camille. That was great. And we do have some questions coming in. Before we kind of get to that, I'd like to give Jahangir an opportunity to introduce our other special guest that we have today, Abdullah, who's dialing in. Do you want to give him a little intro?
Absolutely. Hi, Abdullah. For those who are regulars on this webinar, you've seen Abdullah before and heard about how we are very delighted that he's part of our team here and can also join these webinars to hopefully share some of his expertise with all of you. A lot of the work that I talked about here on the new product introduction stuff, a lot of the brain power that has gone into thinking about some of these things and how we perceive them at a high level. Abdullah is a lot of the mastermind behind some of that stuff, and we wanted that opportunity to bring him here today to be able to offer some insights, especially based on your questions. And also, just as Katie mentioned, one of the reasons we're very well, in addition to the fact that he is an amazing human being, we also are very proud of the fact that he has done a lot of work in his academic life before coming to Ikigai. Which is very well sort of like globally recognized. Recently won a Best PhD Thesis Award out of hundreds of people and their theses in the field of OR, winning the second place at the George B. Danzig Thesis Award. which is a very, very big deal. We love to celebrate it and love to tease him about it too, because that makes sure that he's now the resident expert on a lot of things. So we're very glad Abdullah could join us today to take some of your questions. So Alex, I think you have been paying attention to some of the questions coming in, so I'll let you ask, and then Abdullah can hopefully apprise us with some of his thoughts.
Absolutely. So the first question I'll tackle, there's a couple flavors of it coming in, but the gist is if we're forecasting for completely greenfield projects, so no previous product data, how do we figure out the correct analog product data? And then a kind of similar question asking around, what kind of metadata is needed for product forecast when you have no data? So if you guys wouldn't mind tackling that to kind of kick us off.
Yeah. Thanks, Jangir, for the introduction, and yeah, thank you, Alex, for the question. Yeah, this is, I think, one of the nice things about the approach that we're using. Um, it's flexible enough to take any kind of meta information that the user think is relevant. So, because as you know, like different fields will have, or different domains will have different meta information with which this mapping would make more sense. For example, like what kind of metadata that we use in the past with different clients. Like the basic thing that you would use is, the description of the product in text. Like nowadays we have a very rich, quote unquote, word to vec, right? Techniques that can embed the context of all these different product description and put it in the right context. We could use that as well as other type of data set, or other type, sorry, metadata, like the prices, what else? The price ranges, any like the industry that the kind of market that this product is being sold at, etc. For a new product that the company doesn't have, things can get a bit trickier, right? You may not have an analog product in your catalog, and in this case, what is always that we find always helpful is that there are lots of external data set that you can get your hands into that is relevant to your data set, and then you can do the matching there. It doesn't have to be limited to your own data set. But of course, there will be limitation there on what kind of external data that you can get. But this is where we work with the client to find the best sources of data from their expertise as well as ours, and do the best possible matching we can get.
Awesome. I don't know if there's anything you want to add, Jahangir, or I've got a couple of other questions coming in.
Move on to the other questions.
Perfect. So another question, what kind of expert feedback can be taken into account when you have a low confidence forecast?
Yeah, so as Jangir touched on during the presentation, we try to take in as much expert feedback as possible and make this as flexible as possible. So like even the basic matching, we allow the user to change, as also Camille just showed in the demo. So if we don't feel that given the current information and metadata that we have, we can do proper matching, we would ask the user to help us during this process. The other thing that we would also, we can take user feedback, and as Camille showed, is things like what do you expect, for example, that the range of the yearly revenue would be? And of course, this is the answer that we want to also give, but sometimes getting as much context from the user as possible would help us give a more detailed forecast, but also taking in a more high level expectations that the user have.
Great. Now, another question that kind of just came in. This is about seasonal campaigns or potentially campaign cycles. So, if you're aware of seasonal campaigns or campaign cycles that either you have or that competitors might have, is this something that you would factor in as you're looking to predict demand and, maybe even think about price elasticity?
Yeah, yes, for both. So a common challenge that we have, for example, with price elasticity is usually, for example, you'll see discount at the time frames where you expect more sales, right? Like there is discount during the holidays, right? But that doesn't mean that, of course, all the sales during Black Friday is just because of discount. Usually people decide to buy during Black Friday, even though the discount wasn't that large. And even so, the question is, can we disentangle the seasonal effect from the pricing effect, right, or the discount effect? And this is basically like the main question that we try to answer with our what if technique. Like, can we disentangle the two factors, the seasonal factor and also the pricing factor? And so generally, yes, this is what we try to do. But of course, and it is possible that for a specific company, for a specific data set, this is not possible. But we do like a best effort approach to disentangling this effect and getting the best answer that we can.
Awesome. Now, this is a question about new configuration introduction. Do we have any concrete examples of how we've generated forecasts as it relates to a new configuration?
Yeah. I mean, there are a couple of examples where we went through with different clients. But like let me just give a more concrete but still generic example. Like, let's assume that, for example, you're selling power banks, and then you have different capacity of these power banks, like, I don't know, 10,000 mega ampere hour, I don't know what the units are, and or 20K or 30K, right? And you have these three sizes, right? But and then you see that competitors are selling the smaller size of 5K, for example, and you want to see, like, if you actually introduce this, what's going to happen. And as Jahangir touched on, there are like range of possibilities that could happen. For example, maybe the original three configuration that you already have will still have the same sales when you introduce the new one, but the new one will tap into a new demand, like people who prefer this small size power bank. Or the other extreme is the number of power banks you'd sell would be the same, but just, the configuration will change. So instead of you selling, like, let's say it's 1/3 of each configuration, you'll sell 1/4 now. But usually what's going to happen is something in between, right? And the question is, like, where would we, like, and what point on the spectrum would we settle on? And usually what we do in this case is we have to rely on the market data to get the right like the point that we will settle on in the spectrum. Like, we don't really, if we just use client data, only the client data, it's hard to tell where would we end up, right? But in a few cases, fortunately, you'll find access to some either the other competitor sales or a proxy of their sales. Think of, I don't know, ratings on Amazon, for example. This is not really the number of sales, but it's something that can be a proxy of the sales, and you can use this to gauge customers appetite for this new configuration, and whether they actually only want this configuration, or is just one configuration that they would or are they flexible in terms of the configurations. And you can and this is what we basically use all of this data to figure out where we are in that spectrum, and then make our forecast based on this information.
Now we have one question coming in that I'll kind of generalize, but it's asking about complexity, right? So if you have stocks of products with distributors, maybe you're working with multiple store locations, different price points for different payers. How does Ikigai handle, let's imagine, hierarchies of complexity. Is that something that we are able to take into account? Because, real world businesses are often extremely complicated. So how might we simplify that, or help someone make sense of a forecast where there's multiple layers, multiple stores, and all these kinds of factors at play?
Yeah, I mean, I'm trying not to get into the hairy details here, but it also would depend on what kind of data do you have. Like, if you have the low level data, you know exactly how many items you're selling in each pharmacy, at what is the price point, potentially what are the locations of these pharmacies. All of these things are things that we can handle, and then we can give a more detailed forecast at a, like, store level, right? And then actually this variation in prices is not, from our perspective, a bad thing. It's actually a good thing. This variation in prices can now tell us exactly, help us a lot with the price elasticity, for example. But of course, I mean, there are different factors here that we need to be careful of. But in general, more variation is better for the what if scenario, for example. So I think without knowing like the exact details of the problem, it's hard to give a concrete answer. But in general, this is the type of question that we usually deal with, like a very granular forecast for specific products, even with like varying prices.
Well, and I'll say too, just, I mean, even thinking about somebody where, maybe there's compliance across 50 different states and you're trying to figure out pricing when there's, every state manages something, completely different and there's laws to deal with. I know that's something that we see actually quite frequently with our customers.
Yeah. Actually, Alex, there is something I definitely want Abdullah's opinion on, because I think he spent a lot of his time thinking through these things over the years, and so I'll try to articulate it. And Abdullah, you can keep me honest here. Essentially, when we think of new product, today's topic, new product information, this product that you're thinking doesn't yet exist. Well, in the market, it probably doesn't exist, right? You may know things about it, but you haven't sold any. And then if you also think about the what if scenarios that we've been talking about last time, a little bit this time as well, where you're wondering, could I price something here versus there? You may never have priced that existing product, or definitely a new product, at that price level, right? So you're trying to sort of learn from history to figure this out. Now, historically, I would say a few years ago, maybe up until that time, the answer a lot of people would probably want to say is that if you want to do these sorts of things, you should do some sort of a randomized control trial, right? You want to introduce a new product or not? Should I introduce it? Should I not introduce it? Let me actually go and introduce it somewhere and then get the feedback and then do those sorts of things. And similarly for pricing, right? Is there a unifying sort of mental model that you have that you would propagate people thinking about? Should we always think of this as an expensive randomized control trial, which is a gold standard in some cases, but not possible in many others? Or is there like some sort of are you what you're proposing, is it generally very different from a randomized control trial? I think I'm trying to sort of bring a bunch of sort of meta high level ideas in and see if you have any thoughts for us.
Yeah, I mean, I think this ties in more into the what if and the price elasticity question, for example, but it would still be relevant here. But usually, I think, I mean, at least as far as I understand it, or as far as like with the customers that we work with, like I'm not sure if RCT is something that they're used to do with their products, right? Like unless we're dealing with a software company, or potentially I mean, of course, e-commerce would do kind of A/B testing, but not really with new products, but with like how they're showing their own products. But in general, the engine that we use to do this what if analysis, these different what if analysis, is trying to replicate these RCTs. So basically, sometimes you do have enough variation in your data that there are some natural experiments in your data that you can use to actually uncover an RCT that you haven't done, but it happened just because of some decisions you've made in the past. So, for example, if we talk about maybe these like pharmacy stores, right? Maybe the price was chosen differently in different states for some specific reason, but then this variation can basically induces a natural experiment with which you can say, okay, we almost have an RCT here. Can we get some estimate of the effect? So the question is, can you get as much of your data as you can to estimate the different effects of all of these different decisions? And this is like the mental framework that we have when we deal with this what if question. Especially that in lots of these scenarios, it's not just RCTs are expensive, RCTs are impossible. You can't, for example, give different customers different prices as they come into the store, right? I mean, you may do it in e-commerce, but you can't do it everywhere.
That makes sense, just not very practical. Well, we have time for one more question before we wrap. And I'll take one. It's a question about the expert in the loop. So, as an expert, can you help Ikigai differentiate the key factors on the forecast? So if you come in with a very new low price or a much more performant product, sales impact could be huge. Are you, as the expert, able to kind of come in and make a call about what things are actually making the biggest difference?
Um, yeah, so like the as we said before, like the expert can come in and affect, like change the forecast in different various ways, either by selecting the ranges or also selecting the neighboring products. For example, the range would allow you to say that, okay, I'm actually expecting that I would overperform the market, right? So like if like I don't think I'm gonna sell at this level, I'm gonna sell 10x that, right? And it's something that, of course, potentially we couldn't know just looking at the data, but the client may know for some reasons, and then you could, of course, make sure that the forecasts reflect this belief that you have.
And I'll add on to it. Thanks, Abdullah. I think one other part of this question touches on a very important sort of thing, especially when you are looking at what if analyses. The answer to whether you can distinguish the effect of, you're changing this particular knob, let's say one particular feature, quote unquote, and how it's impacting things. Yes, by definition, if we are supporting a what if, doing a what if analysis on those things, then we would be able to isolate the effect of that particular individual. Now, as a platform on Ikigai, in addition to what if, there are a lot of other explainability features that we have baked in, which we've seen clients across the board need that, because eventually, how do you build trust? And I think there's another question here. I'm trying to tie those together as well, that we have touched in the previous webinars, which is how do you make somebody believe that number one, your forecast has a good quality. I think we have a lot of material on that previously. Is accuracy alone may not be enough. That's usually table stakes, but then can you capture the effect of seasonality and trends and cohorts and covariate information and some of the auxiliary data, external data that you've provided? As a platform, Ikigai provides those almost out of the box that you can sort of get a view on, because that's what everybody asks for when they want to build trust. And also, generally, when you are trying to isolate different kinds of effects and really figure out that if there is a forecast that is appealing to you and making sense, you want to look for those things. Where is the seasonal effect? Where is the holiday effect? As long as you provide those inputs, we believe that good forecasting systems should be able to distill some of those effects out. Now, will it always capture every single thing that you can change? It depends on how the things are being encoded and modeled, of course. But by and large, there is a lot of commonality between what people want to sort of isolate the effects of, or at least get a sense for. You get some of those out of the box. Some of them are part of sort of these what if scenarios. And then you can essentially get different degrees of certainty around the effect measurement. And so that was a sort of a longer answer, but also hopefully something that will encourage people who may not have joined us previously to also dig up some of that information in our past webinars, because we have touched all of those things, hopefully in a little more detail than we have time for today.
Perfect, thanks. And then that's actually a great transition. So we're wrapping up our time today, but if you're interested in any of our previous topics, they will be included with QR codes in the slide deck that we'll share out. Encourage you to check them all out and kind of build your time series forecasting knowledge with us. We will also be sending out 3 resources, one focused on collaborating with data scientists and business leaders. One is a deeper dive on the time to vet concept that we discussed today. And then one is around time series forecasting and actually some benchmark for what we're doing here at Ikigai. So with that, I'll thank all of the great speakers today and Camille Demoist, and appreciate everyone who joined, and hope you all have a happy holidays. Thanks for coming.